Howdy folks, welcome to Super App 101. Really excited to bring this tutorial to you. Before we get started though, I want to invite everyone to come to our Discord and come say hello, tell us what you're interested in building, and we can get you some of the resources that you need to pull it off, and we can help you find teammates as well. So if you're hacking on Superfluid for a hackathon, that's super important because we can definitely steer you in the right direction, especially if this is your first time. With that said, let's jump into hack.superfluid.finance and get an idea of what this jumping off place is. So there's the link at the top. Basically, you can come here, you can get ideas. At the top, we have the ideas billboard, which is just interesting things that we've found. There's also ideas that other people have posted who are looking for teams, and those are going to appear here. And if you want to find a team, you can submit your own information here, and then people can contact you. And we have a big list. So people wanting to build NFT ownership projects and revenue sharing and video streaming using Superfluid. Those are all some of the cool ideas in here, and you can contact these people in the Discord. And we also have examples for what people hacked on from previous submissions. So this is a great place to start, and we have the useful resources link as well there. You can go to our technical documentation, the link to join the server is there, all that good stuff. So today we're going to be building a Holy Grail contract, and that's going to be our super app. That's the fun name for it, and let's dive right in. All right, so the first step is to click the link in the description, which is going to open up the Remix IDE. The Remix IDE is basically just a really fun way, a really easy way in the browser to play with these contracts, so you don't have to download or install anything. So now that we're here, you should see a page that looks a little something like this. On the left, we have a couple tabs. We have the File Explorer tab, we have a compilation tab, and some other sorts of things. So in the top one here, we'll click open our files, open the gists, and then click the gist. And so this is actually how the contracts were just loaded into your browser. We'll select the tradable cash flow contract, and that's where you can start poking around, and I'll start explaining what we're actually looking at. So like I said, this is a Holy Grail contract, which basically creates an NFT or a non-fungible token, and we can stream funds to that NFT. And when we transfer ownership, the funds flowing to that NFT go transfer to the new owner. So if it's flowing to Bob and he's holding the NFT and he gives it to Carol, then now all the incoming stream of money now gets redirected and sent to Carol. So we think this is kind of cool. It's like the Holy Grail has like magical properties, and whoever's holding it gets those magical properties. So there's two contracts here. There's tradable cash flow, which is where we kind of have our business logic and our NFT stuff. You can see at the top, we're importing the ERC 721 contract from Open Zeppelin, which is like a contract library that's standardized, and that is standard in the industry. And then we also have some imports from our other contract, the redirect all contract. So tradable cash flow is where we're going to start today, and then I'll explain kind of the general overview, and then we'll go and look at the redirect all contract, which gets closer to the super app side of things. If you've looked at a token contract before, this one's going to be pretty similar. We are creating a new contract that is the type ERC 721 and redirect all, so it inherits all of those functions. If you're familiar with like classes in Java, it's inheriting all those functions. We have a constructor, and this is basically just setting up who's going to own it, what the name of the token is, what the symbol is, and then you can see some Superfluid arguments here, which we'll talk about in a second. So during the constructor, we initialize our ERC 721, which is our NFT contract, and we initialize our redirect all contract, which is our super app one. And then we do one thing other than initializing contract. We just do one thing, which is to mint a single NFT and transfer it to the owner. And that NFT is going to have token ID 1. And I'll just tell you right now, that's the only one we're ever going to mint, because we don't want to make like a bunch of holy grails. That would be really confusing. So we're just going to have one holy grail for this whole tutorial. This contract can never make any more. Don't worry about that. Of course, if you're hacking and you want to fork this and change it, and that's your you're welcome to do that. What I'm giving you here is just something simple so that we can all be on the same page. And the next function, and actually the only function in this contract, is underscore before token transfer. And this is now starting to get to the super app sort of things. So I'll just kind of give an overview of what this does. Essentially, before the NFT is transferred, this is a hook that says, okay, before I actually, in the ERC 721 contract, update who the owner of this NFT is, I want to execute this function. I want to execute on here, line 43, change receiver. Okay, so let me say that again. So before token transfer, before the contract updates the state and internally says, okay, now the owner is Carol, it needs to run this function, change receiver to. And that's where we have our super app logic. That's where we are going to say, okay, instead of streaming the funds to Bob, let's stream them to Carol now. And so this is kind of a way that we can automatically execute the super app stuff, the Superfluid stuff, when we're just doing a normal transfer of the NFT. Normal transfer, but because it calls change receiver, which is what we're going to look at next, that's when we trigger all the internal super app stuff. So let's jump over to the redirect all contract. Because we only have ERC 721 and redirect all, this is really the only thing that's going to be ERC 721 native, and this is the thing that we're caring about, that is redirect all native or super app native. So let's go over to redirect all contract. Alrighty, so we can see we're importing some contracts here from Superfluid Finance /protocol monorepo, which is our repo which has all of our contracts, which has the SDK and all that sort of stuff. We are importing a remix version of these contracts. So just keep that in mind, that in order for this to work in Remix, I had to make a couple of modifications. But if you're planning to hack on this outside of Remix, then you will want to use the development branch of the contracts. Okay, so we've got some interfaces here. We got super app definitions. Okay. We got an interface for a constant flow agreement, V1. That's where we're going to be doing all the streaming, all the flows, token flows. And then we have super app base. And super app base is going to allow us to register our super app. So the first thing that we have to do when we deploy a new super app is we have to register it with the host. And the host contract is just another way of saying the engine, the Superfluid core, the Superfluid engine. And so our super app is over here, right? And the Superfluid core engine is over here. And the engine doesn't necessarily know how what to do or when to reach out to the super app to tell it, hey, such and such event occurred or this happened, right? Because we want our super app to be reactive. We don't want it to not know what's happening in Superfluid. So when we do this registration step, all we're doing is we're connecting the two and we're saying, hey, Superfluid engine, hey, host, this is my super app. Here's the type of things that I want it to do. And that means now that we're registered, those will get called when certain things change. So when people change their flows and it's now, flowing towards our super app, we want to get notified of that, because that's not necessarily something that would touch our contract. So the host has to execute that logic for us, and or not for us, but has to tell our contract, hey, this person updated their flow. Okay, so we define our contract is super app base. And like I said, that helps us during the registration process. We initialize some variables here for the location of the constant flow agreement and the host contract and all that sort of thing. And then the receiver here, which is going to be whoever's receiving that flow of funds. And then you don't really have to know all the details here, but this is basically the config word is sort of like a configuration of all the options that you want for your super app put into a string, and then Superfluid knows how to interpret that to string to say, okay, when this happens, contact them. When this happens, they don't care. When this happens, contact them, and that sort of thing. So this is like, when should Superfluid reach out to my super app and let us know that something changed? So once we generate that config word, we just call the register app function on the host. It's pretty straightforward, and you can start to see what's listed here: before agreement created, before agreement updated, before agreement terminated. So so we have like when things are changing, that's going to decide when the host calls our contract. So let's actually jump down a little further to some of these callbacks that I was just describing. Here we have after agreement created, after agreement updated, and after agreement terminated. And essentially what's happening is these get called whenever a new token flow is created or updated or deleted that's pointing to our contract. So when anyone creates a new flow to our contract, because we've defined this function and we've called it specifically, has to be named this after agreement created, that means that the host contract, when anybody creates a flow and it's going to our app, because we've registered, the host will call this function when that occurs. And when this gets called, we can do stuff. So basically all we're doing here is we're updating the outflow. So whenever somebody sends tokens into our app, we're just updating how much we should be sending out to Bob or to Carol or whoever owns the NFTs. All right, so now let's dive into what exactly update outflow means. And we have this little context here. For the purposes of this lesson, probably don't need to worry about it. If you see this and you're confused, just copy what you see in this example and you should stay on track. So let's go to update outflow. And this, remember, this is called anytime someone updates, creates, or deletes a flow coming into our super app. So when that happens, what we can do is we can figure out the flow rate that they just started. How many tokens per second did they start flowing in? We can calculate that. And if that is 0, then we need to change our outgoing flow rate. If that is more than 0, then we need to update our outgoing flow rate. And so the way we do this, it looks a little confusing, but we call on the host, we call agreement, and then we encode the arguments and the selector for the function we're trying to call. essentially what's happening here is we have agreement classes, and those agreements are how we manage flows and instant distributions. And there might be more in the future, right? And those are their own contracts with their own logic to them. And when we call the host is actually the thing that's going to update everything. And so we have to kind of encode the logic, what we want to occur for the agreement, but we hand that off to the host. So we kind of have to package everything up and then give that to the host. So this kind of layout is going to be a little tricky when you first get started, but it'll quickly make sense. We just take the selector of the function that we want, and then we pass the same arguments, just like if we were like calling it on the constant flow agreement contract, on the agreement contract. And then we're also passing context around, which kind of makes sure that this is all happening in the same context, in the same transaction, and that allows us to pass data around in between these functions. Like maybe it goes to the host, then it comes back after we do this, and that sort of thing. Don't worry too much about context. If you just copy what's here, you should stay in the green. So the other function, the one that we saw earlier, was change receiver. Now update outflow, right? That's our outgoing flow. That's from the Holy Grail to the holder. But now we have to think about, that's from the sender to the Holy Grail, and then change receiver changes who we should direct that flow to. So essentially, change receiver just receives the address of the new person that we should give it to. It receives Carol's address. And again, it calls agreement. This time, it's not call agreement with context. It's just call agreement. Maybe this one's a little simpler to get. And it uses the selector for delete flow for the old receiver and create flow for the new receiver. So we want our super app to delete the old flow to Bob and create a new flow to Carol. And the value of the new flow is equal to the net flow for our contract. So whatever is coming in, if it's 1,000 tokens per second in, we want to send 1,000 tokens per second out. We want those values to be the same. And then we can update who the receiver is in our internal contract and emit an event. Okay, so, right, that was a lot. Let's just deploy it and play around with it. And if you want to come back and pick this apart a little bit more, you're welcome to do that. Okay, so when we're going to do our compilation, one thing to keep in mind is make sure you're on the same version of the Solidity compiler as your contracts. So in this example, we're using 070. So make sure that you select 070 in the compiler on the left, hit the compile button, and then if it's successful, you should see this. If it's not, then you'll get some warnings. Hopefully it is. And if it doesn't work, please let us know, because it should just work out of the box. All right, so you're probably sick of seeing this screen. Let's go look at something prettier, and then we'll come back to this. Because we want to play around with this and not have to deploy all the Superfluid contracts in our testnet, we're just going to use the Goerli testnet. And the Goerli testnet already has the Superfluid contracts on it, and it has the dashboard, which is what we'll look at now. So this is going to give us some test tokens that we can use to play around with our app. It's sort of like the Superfluid vending machine. We're going to go to the vending machine, we're going to get some tokens, the arcade, and then we're going to be able to play with them with our app. So go to app.superfluid.finance, and you'll want to switch to the Goerli testnet. And of course, Superfluid works on every testnet, including the Mumbai Matic Polygon testnet, XDAI, and so you can choose whichever you want. I'm just going to use Goerli because I think it's the best for these sort of demos and testing. and it's very simple. And when you connect for the first time, and I'm using Carol's wallet here, it's going to ask you to unlock your wallet, and then it's going to detect whether or not you have any test tokens. And if you don't, then it's going to give you some. So you'll see this page, and it'll say, hey, do you want some free test tokens? If you do, then you'll hit yes, and we'll give you some ETH, some girly ETH, and then we'll give you some test tokens as well. And then you'll be able to see those in your wallet. So here we can see I got 0.01 ETH, and I got 1,000 DAI, 1,000 TSDC or USD, and 1,000 USDC. And these are just the unwrapped versions of Super Token or of ERC20. So this is just normal DAI. But if we want our normal DAI to have superpowers, then we gotta upgrade it. And the way we do that is by depositing it into Superfluid. And this actually wraps the DAI token and gives us a new token with a new address, and that allows us to do things like constant flow agreements and flowing tokens that we wouldn't be able to do otherwise. So wrapping is just a normal like two-step approve and deposit. And now we see that we did the approval step, and now it's time to call upgrade. So we'll call the upgrade function. Upgrade and deposit, those are kind of the same terms. We say upgrade because it's like turning your normal tokens into super tokens. Okay, so now instead of in my wallet balance we having 1,000 DAI, we have our Superfluid balance, which is still in your wallet. Don't worry, the tokens are still there. You can downgrade or withdraw them whenever you want and get back your normal DAI, right? They just have more utility now as super tokens. The dashboard is a really cool place to play around. You can create flows, like send it to your friends. So I can select DAI and then like put an amount here per month or per day. But this is going to be, we're going to come back here and play around. So I'm going to switch back to Bob's wallet. Helpful if you have two wallets and you name them. So we'll go to Bob's wallet and reconnect to the app, and we can see what kind of flows we've got going on. I think I already have one flow in here, so we'll see what that is. Okay, so actually no outgoing flows. I just have one incoming flow right now, so that's going to make this a little simpler. I'm receiving 1,000 DAI a month. All right, that's cool. Too bad it's on testnet. All right, so we can see my balance is going up. Good stuff, good stuff. Let's do this. Let's copy the address of our Superfluid DAI, so we can add it to MetaMask with this button. We probably already have DAI in our contract or in our MetaMask, but we want to add DAI X. And so whenever we wrap a token and make it a super token, we just add the suffix, the letter X at the end. So DAI becomes DAI X, USDC becomes USDC X. So we're going to add that to our MetaMask balance. And then to get the address for that token that we just added, you can go to our docs site, which has all of the addresses listed there, or we can do this little cheat here where we go to Etherscan and then we see the address of the token right here. So that's kind of, sometimes I just do that. It's a little quicker. All right, so we have the token that we want to use for our Holy Grail. So this is the token that is going to get redirected if people send it to the Holy Grail. This is the token that we're dealing with. So we were on the compiler tab. Now go down to the deploy and run transactions tab. Expand the deployment arguments here. But before we do that, select injected Web3. And we're still on Goerli, so we see that, that's good. So we were on the right contract now. We put in the arguments Basically, the only difference is that we added the Holy Grail as the name and Grail, Grail, as the symbol, and we're ready to deploy this contract. Let's fire it off. In our constructor, we did our registration. So if the contract deploys successfully, that means that hopefully our app was registered with the host, and it should be able to respond to those callbacks that we learned about. Let's expand our tradable cash flow contract, and we see we get a bunch of functions here. Actually, our callbacks are listed here, but we're not really worried about that. If we copy our address and go to balance of, I'm not sure why that's popping up, but if we go to balance of, we can see that indeed we have one token, which is the Holy Grail. We're holding it right now because we deployed it and transferred it to ourselves. We can also see current receiver. That is our address as well, 3536. That's Bob's address. And we have total supply, all this good, regular ERC 721 stuff like the name and the symbol. So back in the current receiver, let's look at that a little bit more. So we have start time and then we have flow rate. So flow rate is 0 right now, right? We need to start sending some tokens to this thing because right now, whoever's holding the Holy Grail, right now Bob is not getting anything, right? So let's flow some tokens to the Holy Grail. And we'll actually do this from Bob. So he's going to kind of be flowing to himself for a little bit here. So what I did is I went a little faster. I just copied the address of the contract we just deployed. Next to tradable cash flow, click the little copy button. And we will paste that in here to the flow tab. And let's do 100 DAI a month. And everything is in units of tokens per second. Just something to keep in mind. So when you put in like tokens per month, it's going to get computed down into tokens per second. All right, so as soon as this goes, we should actually see 2 new flows. We should see one flow going from ourself out to the super app contract to our Holy Grail. And then because we're holding the Holy Grail, we're going to see one come back to our wallet. And they should be the same flow rate. Excellent. So we can see we have both an incoming stream and an outgoing stream, positive and negative. And if we inspect them, 3835 with 4 leading zeros, 3835. Okay, so these are the same flow rate in and out from my wallet. So one, to the contract and back. So now what? So now let's go back to our app and let's get the address of Carol and send her the Holy Grail. So we will switch to Carol, copy that, and then go back to Bob because he's the only one he's the owner, right? So only he can transfer it. And call it transfer from, and put 2, it'll put Carol's address in the to field. We'll put our own address in the from, and then token ID, remember, is 1 because we only have 1 token. And let's fire this off. Great. All right, cross your fingers. Let's go to the dashboard and see what happens. See, the transaction was confirmed, so that's good. Now, should just have one flow going from my wallet, from Bob's wallet to, yep, there it is. Okay, so now just have the outflow. Let's switch to Carol's wallet and see what it looks like for her. See if she's actually receiving the flow. We can also check while that's loading the current receiver. Yep, now we can see who owns the token. The current receiver, that's Carol's address, and we have a flow rate here as well. So that's looking good. Hopefully on the dashboard that's showing as well. Yep, and there we have it, folks. So we minted our NFT Holy Grail, we sent a stream to it, and we transfer that to Carol, to someone else, and now she's receiving the stream. So that hook got called whenever the token was transferred, before token transfer, to change receiver. And when that happened, our super app updated its own flow to redirect from Bob to Carol. And then because we registered our super app, it was able to recognize that it had incoming streams. So now when Bob goes to turn his stream off, the app isn't going to continue to try to stream out again, because if it has no incoming streams, it can't stream out, right? It needs some tokens to work with, and it doesn't have any, right? Its balance is essentially 0 at all times, because whatever goes into the Holy Grail immediately goes out to the owner. Okay, so that's pretty much it. Hopefully that was enough to get you started. Remember, the nice layout here that we worked with was we had sort of our ERC 721 contract, and we were using the before token transfer hook to execute some of this logic. And then our redirect all contract, it essentially contacted the host using the super app base interface, and it said, hey, let's register our app, and we described what we wanted to happen in our callbacks. So our callbacks get called anytime the flows incoming change, and then we also have our change receiver function, which is going to update the flow going out of our NFT, out of the Holy Grail, and that. So there's a lot here, and I understand it's hard. Like I said, reach out to us in the Discord. We're more than happy to help with anything you need, and we're looking forward to what you hack on for this upcoming event and any future projects. Thanks for listening. I hope this was helpful. See you guys next time.